All right, we have a Lagrange multiplier problem to do today. We're just going to see the mechanics of it. We can read about the method and why the mechanics are what they are in our reading. We just want to do a problem. So let's do this one. We have a function. This is a surface, f of x, y. So there's some surface defined by that multivariable function. And then we have our constraint curve. And this is a curve in the xy plane. And we think of that curve up on the surface. So along our surface, there's some hiking path, and we want to know the maximum height that we reach on that constraint curve. Or if we think of that as a hiking path, how high do we get and how low do we get? And we do this with the gradients. We need the gradient of f. So the gradient of f is y comma x. And we need the gradient of g. So the gradient of g is 2x minus y, comma 2y minus x. So we have the gradient of f and the gradient of g. And the Lagrange multiplier equation is gradient of f is equal to a constant times the gradient of g. When these two vectors are parallel, that's where we're going to have our max or our min for the surface along the constraint curve. So what that actually looks like, grad f equals lambda times grad g, we look at it component by component. So the x component for grad f is y, and lambda times the x component here is lambda times 2x minus y. The y component is x, and the y component of this equation is lambda times 2y minus x. And we have three unknowns in here, x, y, and lambda. And we need a third equation to be able to deal with the three unknowns that we have. So the third equation that we always use is the constraint curve itself. We need the points to lie on the constraint. So now we have three equations and three unknowns, and it's a system, and we have to solve it. And this step could be different in any individual problem. There's some different approaches that we'll see in this example and then in other examples we do in class. In this example, what I'm going to do is I'm going to try to eliminate lambda first out of the top two equations. And the way I'm going to do that is I'm going to divide one equation by the other. I'm going to divide this equation by this one. So on the left-hand side, that gives me y over x. And on the right-hand side, I get 2x minus y divided by 2y minus x. Now the lambda has been eliminated, so that's good. I can now work with the x's and y's here. Let me multiply, I guess cross multiply to get rid of denominators. I'm going to have 2y squared minus xy equals 2x squared minus xy. If I add xy to both sides, that is, and divide by 2, that's y squared equals x squared, or y equals plus or minus x. Okay, so we have y equals plus or minus x. That's two options. Y could be plus x or it could be minus x. We're going to look at both of them one at a time. If y equals x, then our third equation, which remember was the constraint equation. Let me write that down again. X squared plus y squared minus xy equals 9. If y equals x, then what does that equation become? We end up with, let's see, x squared plus x squared minus x squared equals 9. Because if y equals x, then this is an x squared and this is an x times an x. So that is x squared equals 9. So x equals plus or minus 3. So if y equals x, x equals plus or minus 3, this gives us the set of possibilities x equals plus or minus 3, y is equal to x, so y also is plus or minus 3. So those are some possible points where we could have a maximum or a minimum along our constraint curve on our surface. The other thing that could happen here, right, was y equals negative x. So if y equals negative x, then we have x squared plus negative x squared minus x times negative x equals 9. And that looks like, let's see, we got 1, 2, 3x squared equals 9, x squared equals 3, or x equals plus or minus the square root of 3. So if x is plus or minus the square root of 3, y is the negative of x, so y will be negative or minus plus the square root of 3. Instead of plus minus, it's minus plus. The plus on the x corresponds to a minus on the y, and the minus on an x corresponds to a plus on the y. These are where we can have maxes and mins. To find out what we actually have, we finally end by looking at the surface. Remember, the surface is f of xy equals x times y. So f of plus or minus 3 comma plus or minus 3 is equal to 9. And f of plus or minus square root of 3 times minus plus square root of 3 is equal to negative 3. So we have a max at plus or minus 3 comma plus or minus 3 because we're at height 9 on the surface at that point, and we have a min of, a min at plus or minus square root of 3 comma minus plus square root of 3, because on the surface we're at negative 3 at that point. So the max is 9 at this point, the min is negative 3 at this point, and that's how we do a Lagrange multipliers problem.